Okay, Assalamualaikum warahmatullahi wabarakatuh and a very good evening. Okay, so we'll continue our lesson. Okay, previously we already did study or know about the families of polymers or polymer families. Okay, as we know that polymer families consist of thermoplastic, thermoset, and elastomer. And last week we already go through some certain types of thermoplastic, and we will continue. Okay, same topic, okay, same families, which is the thermoplastic, and let's see what else are categorized under the thermoplastic category. Okay, n- okay, the upcoming is thermoplastic family is polystyrene. Okay, as we know that, okay, it is considering a polymer because the repeating unit, okay, or the monomer, okay, which contain styrene. And polystyrene is a synthetic aromatic polymer which is made from the monomer styrene. Okay, so this is called polystyrene because the repeating unit styrene is being repeated many times. Okay, and it created a long change. Okay, so this is why we call as a polymer. And then polystyrene can be a solid or foamed. Okay, and general purpose of polystyrene is clear, hard, and rather brittle. It is an inexpensive resin per unit weight. Okay, so what is the meaning of inexpensive resin per unit weight? Okay, we can see that, okay, even though the use of polystyrene is very large in volumes, okay, but the weight is less. Okay, for example, let's say when you buy a new TV or television, okay, they put polystyrene, okay, to protect or absorb any energy of impact that occur towards the television. Okay, it fills the box actually. Okay, and then it is very big. However, it is still light. Okay, that's why we call it is an is inexpensive resin per unit weight. Okay, so next is about polystyrene. Okay, polystyrene account for 20% of all thermoplastic in commercial use. Okay, means that thermoplastic families, the polystyrene only been used rather in 20%. Okay, it is a very versatile plastic that can be rigid or foamed, and polystyrene is very brittle and poor impact strength. Okay, for sure it's very brittle because, okay, without any forces, it's not without any force, with a little force you can break the polystyrene, and its mechanical properties can be improved by blending with polybutadiene. Okay, and then the qualities of polystyrene are usually versatility, insulation, ease of processing, low cost, and clarity. Horrible wearability does not have chemical resistance like PP and PE. So we can see that polystyrene itself is not chemical resistant. Okay, what happened if you take, let's say, benzene or petrol, gasoline, okay, and you put polystyrene inside? You can see that polystyrene will be dissolved inside this chemical. This is why we say that polystyrene is do not have any chemical resistance. Okay, so this is some example of polystyrene itself. Okay, this is the common use of polystyrene as a food packaging. Okay, but however, okay, despite this thing, polystyrene also being used as appliance, houseware, refrigerators, furniture, toys, and others. Okay, this is an example of toys. Okay, they are made from polystyrene because this is actually an aeroplane toys. Okay, it's made from polystyrene. Why? First of all, because it is very lightweight. Okay, the specific needs of aeroplane is to fly, okay, which is to deny the gravity force. That's why it require a low weight materials to build the airplanes. Okay, so but we can see that, okay, this is an article, okay, that I obtained from the internet. Okay, it's from Malaysia Kini. Okay, Unimed bans polystyrene and plastic straw in campus. Okay, despite Unimap itself, okay, we can see that many university or many places, okay, actually bans the use of polystyrene. That's why when you came and registered in Unimap, okay, it is difficult for you guys to find polystyrenes. Okay, we know that polystyrene is used as food containers of food, as food packaging, and mostly people ban the use of polystyrene. Why? Why people ban the use of polystyrene? So this will be your second discussion. Okay, the discussion will be posted in the e-learning platform. I hope that all of you can contribute, okay, to the question why polystyrene is being banned. Okay, and then after polystyrene, okay, the next thermoplastic family is the polyethylene terephthalate, PET. Okay, so have you guys ever heard, okay, the acronym of PET? What is PET? Okay, PET itself. Okay, I bet, okay, you are not commonly heard what is PET, but you are familiar the items that we made from PET. Okay, so the thermoplastic polyester result from the copolymerization of a diatic and dialcohol under condition that lead to formation of a linear macromolecules. Okay, so this is PET structure. Okay, and then this is the common use or application of PET. First is 55% are made for bottles, drinking bottles. Okay, drinking bottles. Okay, so if you see the drinking bottles, okay, it is made from PET. And then 30% for films and sheets, 5% for automotive and transport, 5% for electric and electronics, and 5% for others. Okay, but mainly PET is being used, okay, to make the water bottle. But how is the water bottle being made? Okay, okay, so let's have a look how water bottle is being made.
Plastic water bottles. They keep you quenched, but how are they made? It all starts with thousands of tiny pellets, primarily comprised of PET plastic. PET, or polyethylene terephthalate, is strong, safe, and makes up about 96% of plastic bottles and containers in the US. Most plastic products are created through a process known as injection molding, which begins with a technician loading the pellets into a giant funnel known as a hopper. However, these days, it's far more common for the pellets to be vacuumed up through tubes and directly into the hopper, where they are measured and portioned for the injection process. The plastic pellets travel down the hopper and into the machine, where they are melted down and injected into molds in the shape of drinkware. For most drinkware, like plastic cups, the process is pretty much complete. A robotic arm removes the cups from the machine and stacks them for the technician to inspect. Lids and squeeze tops are also done in one. As the mold opens, the finished lids are ejected down a chute, ready for assembly. When bottles are injection molded, the process has multiple steps. Initially, the plastic is molded into a small, hollow cone. The cones are compact and thus easier to store. When an order is placed, the cones are inserted onto a conveyor and heated to make them soft and pliable again. Then they are squeezed into a larger mold while air is forced into the center, causing the plastic to expand to the full shape and size of the bottle. It's like blowing up a balloon. When they exit the mold, you have a fully formed and beautiful plastic bottle ready to hold your favorite beverage. Some machines are so enormous that the entire process is completed internally. The plastic is melted, the cones are formed, and then immediately molded into finished bottles without ever being touched by a technician. But we're not done yet, because injection molding is not the only way to make a bottle. This is extrusion molding, a process in which heated plastic is squirted out into long, hollow tubes like large plastic noodles. 3 at a time, the molds clamp around the plastic noodles. Air is forced into the molds, and the plastic tubes expand into the completed shape of the bottle. The bottles are formed, but there is extra plastic to be trimmed. So they are run through a cutter with a heated blade that shapes them up like a hot knife through butter. Now it's on to heat treatment. Without it, the ink used in screen print and pad print will not properly adhere to the drinkware. Our extrusion molded bottles are sent spiraling through a gauntlet of fire and out the other side ready for logos. Fun fact, an easy way to tell if a bottle has been heat treated is to dip it in water. If the water beads up, the bottle has not been treated. A fully treated bottle will come out of the water with a glossy sheen. Bottles and cups are great, but what really takes them to the next level is branding. So it's off to the screen printers to add your name and logo. The final step is packaging. The bottles are sealed in plastic, boxed up, and sent to lucky customers all over the world who are looking to expand their brand. There you have it, plastic water bottles. A great way to hydrate and promote your brand.
Okay, so this is a process on how to produce plastic water bottles or plastic bottles. Okay, so can you define what is the process of making plastic bottles? And then, okay, despite of using injection molding, what other process or equipment, okay, can be used to create or to produce plastic bottles? Okay, okay, so that's all for our lecture. Okay, this is your attendance for this week lecture. I hope that you